Good evening, my YouTube viewers. Crystal here. I wasn't going to make a video tonight, but I woke up when I found out some things. And so I decided, oh, well, since I'm wide awake now because of what I found out, I may as well go ahead and make the video that I was intending to make. The title of this video is going to be Predicting Probabilities with Python. So this is a competition question from the Analytics VidHaya website, and it was cross-sell. It was the cross-sell competition. Basically, I've been trying to use the cross-sell competition all day long, and there's an error on the website, so I wouldn't accept it. But I did the best job that I could do and decided to go ahead and stick with it, even though I can't tell you the exact score that I got. What I will say is the people who've been watching my videos, you know that I try to use a standard procedure whenever I'm writing a program, and I don't do anything fancy because I don't know how to do the fancy things. If I knew how to do really fancy things, then I'm sure that my score would be higher. But because I don't know how to do the fancy things, I just get a basic score. But maybe whenever I learn how to do the fancy things, my score will improve. So this program is on my GitHub account, so you can go into my GitHub account and follow along with me if you want to. The first thing we have is the problem statement. I just included a couple of sentences in the problem statement. So your client is an insurance company that has provided health insurance to its customers. Now they need your help in building a model to predict whether the policyholders' customers from past year will also be interested in vehicle insurance provided by the company. Your client is an insurance company that... anyway, sorry about that. It's the same sentence all over again, but what you have to do is you have to predict probabilities. So the first thing we did was we load our libraries. And we loaded NumPy, Pandas, and Seaborn. And then what we did was we loaded the data sets. Now these data sets were too big for me to put on GitHub, and since they were too big for me to put on GitHub, I had to put them on my drive. So if you want to do the program yourself, then what you have to do is you have to go onto the Analytics VidHaya website, and you have to download the train file, the test file, and the sample submission file yourself. So we downloaded the train file, the test file, and the sample submission files so you can see them. The response is binary, and then the test file is exactly the same format as the train file, with the exception that it doesn't have a response. The sample submission is going to be an ID and a response. Now, what is unusual about this is because it looks like they want the outcome to be binary, either 1 or 0. But if you actually look on the Analytics VidHaya website on that particular cross-sell competition question, they said that they want you to predict the probability. So I think that the sample sub is a bit misleading because they say that they want you to predict the probability, but then the outcome looks like it's going to be binary. Then what you do is you check for null values. Fortunately, in this instance, we didn't have any null values, so that's good. Then what we do is we do a disk plot on the response, and you can see that this is an imbalanced data set. You can see that you got 46, 7, 10 of class 1 and 334, 399 of class 0. So this is definitely an imbalanced data set, which is going to need to be taken into consideration. Then what we do is we look to see what type of columns there are on the data sets. And we've got a few object columns. We've got 3 objects to be precise. And these objects are going to have to be converted to numeric. So the only way that I know to convert an object to numeric is to use the label encoder. So I use the label encoder to transform the gender, vehicle age, and vehicle damage on both the train and the test file. Then the next thing we do is we define our X, Y, and X test. So Y is your train response. X is your train drop response and drop ID. And X test is test drop ID. And then what we wanted to do is we wanted to see the shape of X, Y, and X test. Now what we do is we split the training set for training and testing. We use train test split to do this, and we do it on the X and Y. We have a random state of 1, test size of 10%, and stratify is yes, and the reason why is because when you've got an imbalanced data set, and that does like a strata field. It does a strata field in it if you said stratify equals yes. So now what we want to do is we want to count the values of the validation set. So you have 33440 of 0 and 4671 of 1. And so we've got another visual representation of this, and you can see that it's still an imbalanced data set. So what we do is we define our class weights. So class weights equals dict, zip, NP unique, Y train, class weight, compute class weight, balanced, NP unique, Y train, and then Y train again. And that is the formula that I got off of either stack flow. So now what we do is we define our model, and I use XGB classifier. Typically, I get the best response from XGBs, but I also get a good response from HIST, gradient boost, and also a good response from MLP. And sometimes you can get a good response from Keras if you can get it to work. So with XGB classifier, the first section of it, we do K-fold equals stratified K-fold, and we get an 87.74% accuracy on that. And the next thing we do is we run our model, and you have to set up the parameters that I have here on this program, and you have to make sure that class weight is set up for class weights. So you can try it if you want. You can try class weight equals balance or class weight equals class weights to see what the best score is, but I just used class weights. Anytime you have an imbalanced data set, you have to do something to try to balance the status set, and I don't really want to use SMOTE or near miss because that's just synthetic sampling, and I'm not really keen on that. So we got 99.95% accuracy on this XGB classifier on the X train, Y train, which is very good. Now what we do is we make our predictions on X val, and we got an 82.12% accuracy on the X val, Y val. And so you can see I composed a data frame so you can see what the outcome is, the actual and the predicted were. We had a confusion matrix, and so you can see the confusion matrix as well. And then we did some other formulas as well: accuracy, precision, and recall. So what we did was we counted YPRED, because YPRED equals model predict X val. So we calculated YPRED. So 0 equals 32871 and 1 equals 5240. We did a graph of YPRED, and you can see it's still data imbalance. Now what we've done is we've made our predictions on X test. We've done a graph on the outcome of X test. And then we've also put the pred, which is what the prediction of the X test is, and you had 1095780 and 17459. Now what we're going to do is we're going to predict the probability. So probability equals model predict proba X test, and then you see we have brackets, colon, comma 1. That just tells you that you're looking for the probability that the individuals would be interested in buying the insurance. Because whenever you do the probabilities, you get an array with 2 columns, but we only want to have the probability that they'll be interested in buying the insurance. So what we did was we put the final result into a data frame, and so it was a bit ambiguous because Analytics Vidhya website is down, and so it wouldn't let me check my results. So you don't know if they wanted a binary result or a probability, but I went ahead and used the probability because that's what they were asking for. They were asking for a probability. So we put our final result in a submission, and then so this is the data frame that was submitted to the Analytics Vidhya website. And if the Analytics Vidhya website had been working, I would have been able to tell you the result that I got. But because it's not working, I can't tell you the result. But hopefully, with any luck, the outcome was going to be something similar to the Y-val, which would be 82.12%. So that concludes this presentation on the cross-sell question on Analytics Vidhya, and where we predict the probability of whether someone wants insurance or not. And so you always can look on my GitHub website and get the program yourself if you want to get the program and practice with it. And that concludes my presentation. If you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I've got my email address in the description down below for my PayPal account to make a donation. And the reason for that is because I don't have enough subscribers to monetize, so the only way I can make any money on this account is to ask for donations. And thank you so much for watching my video, and I look forward to making the next one for you.